Vivek, can I get your introduction so that I know a little bit about you? So that way I'll be able to modify the course agenda, right? Just to want to know a little bit about your technical background, and we can
Uh-huh.
go ahead from there. Yeah.
Sure. My name is Vivek, and I just done with my master's in NPU in the stream of computer science, and I did my bachelor's in information technology. So technically, I'm in the bachelor's and master wise from technical background, but coming to experience, I worked as a recruiter couple of years in India, but not into technical side. So I'm very much new to the technical field actually.
What you've done in Masters in Information Systems, have you done any projects in there?
I did a capstone project, which was a campus recruitment system, which includes Java and HTML, and the background database we used Oracle.
Okay, okay.
Yeah.
That's good. That's good.
And yeah, masters in computer science and bachelor's in information technology.
Great. Okay. All right, let's go ahead and get started with the agenda for today, which I'm going to drive you through the concepts of clouds and models in cloud. If you think that my audio is not clear, or if there is some problem with my audio, the voice drops sometimes, please do let me know. Unmute yourself um, and speak up. Or you can also put that in the chat as well. There's no problem at all. So that ways I will know
Okay.
how the delivery is. Yeah. So
Yeah.
basically,
Okay.
AWS SysOps course. So we'll be focusing a lot more on administration than development. I'll show you scripts as well at the end of the training, but then moving forward, at least to start with, it will be an AWS administration class. I understand that AWS is a very high level class, and that's why we will not go ahead and start off with AWS directly. I will tell you the basics of IT infrastructure first, how it evolved and things like that, so that you will get an idea about how it was earlier and then where we had to go. So we'll start with cloud concepts and models. Tomorrow we'll start with uh, virtualization. Now, one question for you: have you used any virtualization tools like VMware Workstation or Citrix or maybe VirtualBox? Any of those softwares?
Y- yes, I did use VirtualBox.
Okay. Have you used that as well, Bandhavi? Bandhavi, have you used any virtual tools? No. Okay. 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 No problem. All right. So I suggest that you download one of these tools, either VMware Workstation, which I'm typing it here, station, or you download a VirtualBox, which is from Oracle. This is a freeware. VMware Workstation is not a freeware, so you may get a trial period to give that a try. I'm going to show that to you tomorrow, how to use VirtualBox or even the VMware Workstation for that matter, right? So great. Let's go ahead and give that a start now. I hope you can see my screen.
Yes.
Okay. So we'll talk about all of these concepts, which is the essential characteristics of cloud computing. Nandvi, you may notice that some of these are repetitive stuff, which you may have heard of this during the demo class, right? Vivek, I'll send you a link to the demo class so that you can take a look at it during your free time, right?
Sure.
So, all right. We'll talk about the essential characteristics of cloud computing, the service models of cloud computing, deployment models of cloud computing, who's responsible for what, etc. So we'll also look at the case studies. Now, we did look at the definition of cloud computing yesterday, but one more time as a refresher. Cloud computing, I mean, you see a definition out there from top to bottom, and that definition is given by an organization called as NIST. NIST stands for National Institutes of Standards and Technology. So it's about 180 years old organization. You can even look about that on Wikipedia and learn more about it. But then they gave a definition for cloud computing and say that cloud computing is a model for enabling ubiquitous. Ubiquitous means something that is present everywhere, um, and convenient on-demand network access So it must be accessible from anywhere. So when you're accessing cloud, take a look at your Gmail for that matter, or Yahoo or Hotmail. You will be able to access it from anywhere at any point in time. You will be able to create an account at any point in time without the interaction from Google or Amazon or Hotmail or Outlook or Microsoft for that matter. So there is a minimal intervention or interaction with the service provider, right? So they can be rapidly provisioned. Now we're just not talking about email accounts here. We're talking about various resources that can be provisioned in the cloud. Now those resources are networks, servers, storage appliances, applications, and services, right? So any one of these or all of these should be, you should be able to create them without the intervention of the vendor when you want it, at your convenient time, from any device, anywhere that you want. That's what a cloud computing model is. So being said that, I would like to tell you that cloud computing is not new. We have been using that ever since the evolution of internet, isn't it? So
Yes.
Yahoo or Gmail, they always existed ever since the evolution of internet. So it's always been there, but it's just that the corporates or the enterprises have started to utilize those features now, right? So that way it becomes easy for everybody and cuts down the cost as well. These are the 5 key characteristics of cloud computing. One is on-demand self-service, there's rapid elasticity, measured service, resource pooling, and broad network access. So these are the 5 key characteristics of cloud computing. It's not specific to Azure, not specific to AWS, not specific to Rackspace or DigitalOcean or IBM Software or any other cloud computing vendor. It's not any specific. It is vendor neutral. So it is on-demand self-service. It is rapid elasticity must be there, measured service, resource pooling, and broad network access. So these are key in any cloud service vendor. Let's go ahead and take a look at them one by one. An on-demand self-service means you as a customer should be able to select the resource that you want. You want to create an email account, or you want to create a server or a database or an email or a directory or a folder or a storage. Well, you select it and you get it, right? And on top of that, you should be able to access it from anywhere at any point in time. And the day you do not want it, you should be able to rapidly deprovision that, degrade it, or even upgrade it at any point in time. So it should be on your demand, not the vendor's demand, right? So it is a self-service portal from where you should be able to provision the resources. Right? Good so far, everybody?
Yes, we are good.
Okay. Now, what does rapid elasticity mean? Now, you might have seen that during an e-commerce or during a festival time, or New Year or Christmas season, there is high amount of traffic. There's volumes and volumes of traffic that is hitting the website. So at that point in time, the web servers may slow down. Now, that's really a panic situation for the administrators and the CIO of the company as well, where the reputation is at stake. The customers may think that, hey, the website is going very slow, so let's go to some other website and purchase our commodities that we are looking for, right? So it's important to rapidly provision new servers when a threshold is breached. So when I say threshold, I'm talking about various resources like CPU, network IOPS, or anything for that matter. So let's say the CPU reaches about 60%, you should be able to provision a new server. The CPU reaches more than 80, you provision 2 more servers. So that way is the balance between the servers can easily be done. So that ways the customers will not face a lot of problems or even a lag or latency in the network. So elasticity is a way in which you can provision the servers, and not just that, when the traffic is low, you also have to deprovision the servers. So rapid elasticity is provisioning the servers when a threshold is breached, and deprovisioning the servers when a threshold really comes down to a certain level. Right? You understand rapid elasticity? Okay, Vivek, thank you. Bandhavi, yourself as well? Okay. Now,
So, sorry to interrupt. One quick question, like you said rapid elasticity. Sorry, if you use 60% of server, it allocates one server, and if you use 80% of a server, it allocates two. So, will that be done automatically, or we need to implicitly provide the details, like to create a new one?
yeah, two things. Thank you very much for the question. Two things. One is the numbers that I gave, 60 and 80, were just hypothetical and for an example. These are not hard
Okay.
coded. You will have the option to configure 60 or 80 or 100, whatever you want to do, you can configure that. Second part, coming to your question, it is automatic. You don't have to do anything.
Okay.
So when
Okay.
it actually provisions a server, you can set up an alert. Okay, now it is 60%, and then you get an alert on your phone. You may be dining somewhere with your family or you're out somewhere. So
Yeah.
you will have the provision to get an alert on your phone to see what's happening with the servers. You can get that done.
Okay.
And we will do that.
Sure.
We will do that.
Okay. All right.
Okay. Now, in continuation to your question, I would like to say that, just in case you feel that my rate of speech is high, I'm talking a little bit faster, feel free to interrupt me at any point in time by unmuting yourself, or if you don't want to unmute or talk, you can put that in the chat. I ask me to slow down or explain that concept one more time. I'd be really happy to do that. My objective is not to complete the course. My objective is to make sure that you understand these concepts and take these in real life and start implementing these things, right? So I'm not in a hurry to complete the subject,
Yeah.
right? But out of certain things, because I'm on calls the whole day with different customers, I may be talking a little bit faster. But just in case you think that I'm talking faster and things are just going above your head, you have the right to stop and then ask a question right there and interrupt me. Okay?
Sure.
Thank you. All right. So those was the first two things, which is on-demand self-service. Second is rapid elasticity. The third one is measured service. Measured service is where, you should be able to measure everything that you're consuming in the cloud. So you have provisioned four servers. One of those servers is 4 GB RAM, two CPUs, 1 TB of hard disk. There's other one which is just for test purposes. So that's just 1 GB of RAM and one CPU and just 30 GB of hard disk. And both of these are Windows. And remaining two are staging servers or production servers with Linux platform. So you should be able to calculate what will be my weekly bill and the forecast as well as to what will be my monthly bill moving forward. So what you're using must be measured for billing purposes. Any vendor cannot just bill you based on nothing. They should have the real numbers as to how much you have used, how much IOPS have been consumed on the hard disk, the disk RPMs, the CPU spikes, the RAM utilization. All of that must be there on the portal for you to go and look back and see, hey, why did I get so much of bill, right? Month on month. So you should always be, able to go back to previous month, just like your phone bill. You can look at the itemized bill, how many numbers you have called and the call duration and everything, right? So even here you will be able to get that by the instance, by the region, by the data center, by various things that you can filter out, by the business units. So that ways it will be very really helpful for you to understand why did you get an X amount of bill. There is no assumption here. Okay? There's no rental, there is no contracts, there's nothing. So if you want to use it, you use it, and if you don't want to use it, you can get rid of that account. Yeah. The fourth one is resource pooling. Now you might have heard that we can provision servers in the cloud. Now one thing is that when you provision a piece of server in the cloud or anything in the cloud, it will be hosted somewhere on a physical server, right? Like you see there, that's a kind of a rack server that you see, and that rack server will have multiple virtual machines. maybe tens and fifteens of virtual machines. But you may be owning just one piece of it. The rest of them may belong to other customers. 10 servers on a physical dedicated host will be owned by 10 different customers. So it is not mandatory that the entire rack belongs to you. This is called as multiple or multi-tenancy. When there are multiple tenants living in the same building, it's called as multi-tenancy. In the same way, when there are multiple servers or multiple resources belonging to different customers on the same rack, it is called as multi-tenancy. So the resources are being pooled by various people or various businesses or various customers. Got it? Okay. Okay. Right, so that's an example of resource pooling where there are multiple customers using the same software, right? One example is multiple users with dedicated space and there's a single environment for them. What is broad network access? Simply means that you should be able to access it from any network at any time and at any location, and the backbone is the internet. If internet goes down, of course, you'll not be able to access anything in the cloud. And you should be able to access it from any web-enabled device. So these are the 5 key characteristics of cloud computing. There are other terminologies as well. Terminologies, important terminologies like chargeback. So let's say you are the finance guy for a big IT firm, and the finance guy gets a bill at the end of the month and say, okay, you got to pay about $4,625. Now you got to split that up and charge them back to respective business units and say the web application team used about $560, the virtual machine team or the virtualization team used about $1,000, then the business unit, the actual customers who are facing the internet, had used the rest of the amount. So you should be able to charge back to them based on the resources that you have utilized on the internet, right? That's chargeback. Are we good so far? Before we move to service model.
Yeah.
Yeah, Vivek, you got a question?
No, no, I'm good. Yeah, we are good.
All right. So these are the certain service models on the C, but then the first, the top 3 ones, software as a service, platform as a service, and infrastructure as a service are the major ones. The rest of them are the byproducts or children of the top 3 ones. So software as a service, platform as a service, and infrastructure as a service are the main ones. So let's talk about them one by one. Well, we have been using software as a service for years now, at least a decade. Talk about Gmail or Yahoo or Facebook or Dropbox. These are all the examples of software as a service where you just have to log in with the user ID and password, and that's it. There's nothing much you can do about it. There's just customization on the front end, little bit of customization, drag and drops, maybe upload pictures. So very basic functionality has been given to you. So you're just using a software as a service, which means that um, you do not have to set up an Exchange server at your home or a mail server at your home to send and receive emails, right? So that is software as a service. You're using software which is called as Microsoft Exchange as a service. You never have to set up. So email as a service. So software is delivered to the customer offshore. You do not have much access out there. Just type in your user ID and password and that's it. You're done. You don't have much privileges out there. You cannot restart the Gmail servers. You cannot patch the Microsoft servers. Right? It's all their responsibility. Platform as a service is where you are focused on the developer market. That is mostly the databases. So you as a database guy would love to have a cheap solution or a cost-effective solution for the databases. Let's say, Vivek, you got a great idea and you want to start developing an application. And that application, yeah, so you got a great idea and you want to develop an application, and that application needs a database, and that database must be of cutting edge technology like Oracle, and then it must be sitting on a hardware with at least 16 GB of RAM with couple of cores of processor, and must be also geo-redundant backups, and all those things must be there. It's not going to be really working out as an individual, but then you will need investors to purchase such an hardware, right? Because that's going to be really expensive. So that's where the platform as a service serves as a boon, an advantage for developers like you and me, and said, okay, we can just hire or lease or rent a platform. Let's rent a database, right? So you want to develop a mobile application for which the backend is a database. It will really be helpful if you can just lease out or pay as you go based on the demand and based on the IOPS or the network utilization that's going up and down on the database, and instead of just purchasing that thing upfront. It's more like renting a space rather than buying a space. You're not buying the whole server, just renting it. Use it for 3 months. If you like it, you keep it. If you don't like it, you just destroy it and terminate that. But if you like it, you pay as you go based on the demand and based on the forecasts upon how your customers are growing, right?
Yeah.
Okay. Infrastructure as a service is a great advantage for the startup companies where you would like to set up servers, racks, switches, firewalls, data centers, virtual machines. All of that in the cloud can be set up with infrastructure as a service. The great examples are here for the course which you're taking here. Amazon Web Services is a great platform for infrastructure as a service. One of the questions that somebody asked me: does Amazon Web Services provide infrastructure as a service, or platform as a service, or software as a service? But I would say it's all in one. It's a one-stop shop for all of them. You will be able to provision servers, racks, firewall switches, databases, emails, identity and access management, everything in one single place. And that can be done with Azure as well, right? Okay.
Okay.
Like I said, the rest of them are just byproducts of software as a service, platform as a service, and then infrastructure as a service, as communication as a service. If you want to talk, a couple of years ago, people were a big fan of BBM, which is now deprecated, like the BlackBerry Messenger. It's gone now. And then we are using
Yeah.
everybody, uh, every single app in this world is using WhatsApp now. So as Gmail servers, so all of that, any place where we are chatting and talking and calling with the help of cloud platforms, that is communication as a service. And then data as a service, where you can store information, which is like Dropbox, and then SkyDrive, Google Drive. All of that is data as a service, where the vendor will ensure that your data has enough integrity and never compromised, right? You should be able to administrate, do collaboration as well, give permissions to other people, and then also move the data between one platform to another. So that's what data as a service is. Business BPaaS, which is more of a business-oriented stuff, where talk about call centers where they have a specific um, workflow. Workflow is like the agent receives a call, it goes in the queue. If the agent is free, he picks it up. If it's not free, it goes in the waiting queue again. If it's free, he picks it up and is done with the call. The call duration is then logged and shows up in the screen. Once it is done, a survey is automatically sent to the customer. So that is a workflow I'm talking about. All of that can also be designed in the cloud. That is business process as a service. So it says it supports multiple languages and multiple environments, different kinds of environments. Yeah. Now, X-axis anything as a service. Now, the different people or different customers have come up with various solutions. One is monitoring as a service, desktop as a service, testing as a service, disaster recovery as a service. So all of these are comes under anything as a service. But then, like I said, the top main ones are infrastructure as a service, platform as a service, and software as a service. And rest of them are just byproducts of it. Are we good so far?
Yes, sir.
Okay. Bandhavi, you happy as well? All right, great, thank you. Now we got various deployment models in the cloud computing. Now there's private, public, hybrid, and community cloud. Let's talk about them one by one. Um, Traditionally, we always had these platforms, they servers. So you had a web server, you had an Exchange server, an email server, an SQL server, database server, an Linux server. So you'll have tens of servers. For every application, you will have a server. And let's say every server will cost about like $3,000 or $4,000. So for 10 servers, it's going to cost $40,000 and one time capital expenditure for the company. So the expenses really go high when they purchase that. On top of that, we're not doing an optimum utilization of resources. When I say optimum utilization of resources, it means that you're not using the resources which are assigned to the server to 100%. Again, what I mean is, let's say the server has 4 GB of RAM, and even your laptop has 4 GB RAM or 8 GB or maybe something more. Have you ever used it to at least 80%? No.
No.
No. The hard disk is, let's say, 1 terabyte or even more. Have you ever used it to at least 60%? Where is your investment going? But you have already paid for it, isn't it? You have paid for the entire 4 GB. You have paid for the entire 1 terabyte of hard disk. The i3, i5 or i7 processor that you have purchased, which is 3.5 gigahertz or 2.4 gigahertz, which was never, that didn't even ever cross 500 megahertz. It never crossed that. But then the investment has been made for 3.5 gigahertz, the entire i7 processor. Assuming that you may need it sometime in the future. But where is your investment lying? It's just sitting waste, right? So that's where organizations thought of it and said that, okay, let me do dynamic allocation of resources. So instead of assigning resources statically or giving it one point, you do it dynamically. What does that mean? It's just like your father or papa giving 10,000 rupees or dollars, not dollars, that's a lot of amount, but let's say he's giving like $500 as a pocket money, and it just gives it to you at once. Well, rather than doing that, we put that in a bank and give you an ATM so that you can use it as and when you need it. But the upper limit is still $500, right? So here we say that in virtualization we say that, okay, your upper limit is 4 GB of RAM and that's where you can go up to. But then we are not assigning it 100%. 4 GB is not assigned to the 100%, right? So I'm going to draw a couple of pictures here to make it more understandable, because I understand that not everybody may have experience with virtualization. I want MS Paint. Okay, that's MS Paint. So what happens in the traditional infrastructure is that you're going to build up servers like this. That's a web server. That's your SQL server. Hey, by the way, can you see the MS Paint?
Yes, I can.
All right. All right, great. So that's a web server. That's an SQL server, and then that's an Exchange server, and you got a couple of Linux servers as well. And like that, oops, sorry. And like that, you will have multiple servers in the infrastructure. So that's how we used to do like 8 years ago or 10 years ago, right? We got to build up servers and servers and servers, and there is a life cycle for a server. After 3 years, nobody's going to talk about that server because that server is deprecated. Today, do we even talk about dual core? We don't talk about it. Somebody's gonna laugh if if my laptop has dual core or core 2 duo or an Atom processor, right? That's very old now. Or even P4, Pentium 4 was a big buzzword like 8-9 years ago, and nobody uses that now. We are in the I generation now. We talk about i3s, i5s, and i7s, right? This is very expensive model where we are purchasing or procuring one server for every application. Now this moved from traditional infrastructure. Now I'm going to name it as well. This is traditional infra. That is traditional infrastructure. Now that moved from traditional infrastructure to something we call it as virtualization. Virtualization was a big buzzword again. Virtualization was a big buzzword where hypervisors, people spoke about hypervisors. Now that was a big buzzword around 2009, 2010, right? Even now, people love VMware. Yeah. So what happens is in virtualization is that you purchase one big bulk server, and that will have humongous amount of memory, like 128 GB of RAM. That's on the lower side that I'm saying. And then it will have couple of processors, like at least a server-based Xeon processor, right? And that will be connected to an external hard drive, I would say, or a storage, not a hard drive, but a storage, which is called as storage area networks. You know what that is? Storage area networks? It's called as SANs. I would like you to make a note, keep a paper and pen handy, make a note as much as possible, keep scribbling around so that ways you can always, Google for these words or do more research on that front, right? And you will be able to understand how it
Yeah.
evolved, how the technology has evolved from where we are today and where it was and where we have to go, right? So keep a notepad and pen and paper handy. That will be really helpful to refer back at any point in time. Yeah, this video session is getting recorded and that will be shared with you. But again, you're dependent on internet. If you have pen and paper handy, you can read in the bus, you can read it in the bed, or go to college, in the library, wherever you can read that. And yeah. So anyways, that's got humongous amount of memory. So instead of putting an operating system on it, what you do is put a hypervisor layer, right? It's called as a hypervisor layer. I'm gonna put that here, hypervisor layer, right? And then on top of it, you'll create multiple virtual machines. Call it VM1, VM2, VM3, VM4, etc., etc. And each one of them will act as a application server. So let's say is a web server, this one is an exchange server, this one is an active directory server, and this one is a Linux server. So that ways you will have multiple servers. The best part is that the day you do not need this server, you can simply right click and delete it. But in this case, coming to the traditional environments there's always been a tough job. There's always been a tough thing. I'm trying to find a pen here. Yeah, this is the traditional environment. If you want to get rid of this server, it's always a tough job because you just cannot throw it on the road. It has to go through a process. E-waste, right? That will eventually end up in third world countries somewhere. But here in the virtualization or hypervisor front, you just have to right click and delete them, right? There are several vendors. Yeah, go ahead. You have a question, Vivek?
No, no, I'm good.
Okay. There are different vendors in virtualization space, right? So there are a lot of companies that have come up. Microsoft calls it as Hyper-V, and then VMware calls it as VMware ESX. Then there's Oracle, then there's Citrix, lots of them, right? Again, within virtualization, there are two things. One is a type 1 hypervisor. And other is a type 2 hypervisor. Welcome, Sidhu. Good morning. So there's a type 1 hypervisor and there's a hypervisor. There's a type 2 hypervisor. There are two kinds of virtualizations there, right? A type 1 hypervisor is something similar to the model that I just made here, something like this. That's a type 1 hypervisor where the virtual machines will be interacting with the hypervisor layer, and the hypervisor layer interacts with the hardware. So the moment the server needs X amount of RAM or X amount of processing capabilities, it will contact the hypervisor layer, and then the hypervisor layer then communicates with the hardware or the real platform and then gives it back to the server. But in type 2 hypervisor, what you have, okay, just a minute. All right. In type 2 hypervisor, what you have is another layer here, another layer, and this is the operating system layer. Operating system, right? Correct. So that's it could be Windows 2012 or 2008, right? Any of those operating systems. Now on top of it you install a hypervisor layer, right? I have a VM here. So I've got VMware Workstation. I've got VMware Workstation installed. I've just launched it. Start, yeah. So I got VMware Workstation installed on my machine, and that's how the interface looks like. So what's going on here is, number one, I've got a laptop that has 8 GB of RAM, and the way I look at the laptop configuration is just go to MS Info 32, yeah, on start run and hit enter and say okay, and then picks up that screen. So it's got about 8 GB of RAM. It's an i5 processor. It's a pretty good machine, pretty fast as well. So it's got a hardware on top of which I have what, the Windows 7 operating system, and then this hypervisor layer. On top of this hypervisor layer are sitting these virtual machines, right? So is this type 1 or type 2?
It's type 2.
It is type 2. Right. Type 1 is ESX, VMware ESX, where there is no operating system. It directly sits on the hardware and then you communicate with that. Right?
Okay.
Okay. So I'm gonna give you homework here just to make sure that you do all of that stuff. Do research on do research on virtualization, specifically the differences between what, Hyper-V and VMware, yeah, type 1, sorry about that, type 1 and type 2 hypervisors, all of that. On top of that, you also got to give a quick read about public, private, the SAS, PaaS, and IaaS. What are those? Then what is public, private, and hybrid networks? So you gotta understand all of those. So that's your homework, and I'll paste that in the chat here. So always make sure that you have a pen and paper handy. Yeah, let's not forget the traditional way. Yeah, we got laptops, we got iPads, PDAs, different devices, but notebook and a pen is always a friend. Okay.
Okay.
All right. So let's go back to the PowerPoint here, and I hope you understood all of those concepts. So what is a private cloud? A private cloud is a cloud environment which is within your infrastructure, within your company. Nobody from the external world can access your private cloud, right? Now your question may be, hey, what's the difference between VMware, the hypervisor stuff? It is still within my company, and you're saying that private cloud is also within my company. What's the difference? You understand the question? Forget about the answer at this point. You understand the question? Everybody.
No, can you say that again?
Right. Bandhavi, do you understand the question? Yeah, okay. And Sindhu, do you understand the question as well? I want it to be interactive. Now Bandhavi said yes. So can you tell me what you understood? I think just for the benefit of Sindhu and Vivek, they did not understand. So Bandhavi, can you tell me what the question was? Bandhavi? Okay, so move on. Right, VMware is also doing the same work in the organization. So what I meant, Vivek and Sindhu, is that, yeah, Bandhavi, you're right. Thank you. Vivek and Sindhu, it's for you. The VMware environment is within your infrastructure, right? VMware environment that you have is within your office, and nobody can access it from the internet or from the outside world. Whereas in the PowerPoint, I'm saying that, let me pick up the PowerPoint. Yeah. PowerPoint, I'm saying that it will be accessed only by the company personnel. The hardware and other companies' ownership lies within the company. Then what is the difference between virtualization and, yeah, what is the difference between virtualization and private cloud? Now you understand the question, Vivek?
Yeah. So
Yeah, you are on mute.
sorry. So I think in VMware we had a limited access, like constrained resources. Whereas coming to cloud, we have elastic resources we can use to the amount we want, and then we cannot use it if you don't like it. So
All right. Yeah, absolutely. Absolutely. That's a very good way to look at. So we're talking about cloud here. When we talk about cloud, we're talking about the definition of cloud. You're talking about the definition of cloud and saying that um, it should be rapidly provisioned without anyone's intervention or without anyone's interaction. It should be measured. All of these are not there in VMware or in internal virtualization environment. If I as a developer want a virtual machine, I still need to contact the team or the infrastructure team and say, hey boss, can you create a machine with Windows 7 on it and then give it 4 GB of RAM and make it 2 CPUs, and then it's going to take a week to get that done. But when I talk about private cloud, it is on demand. That means there will be a portal, an internal portal where you can log in, create virtual machines, do your job, get that done, and delete that virtual machine. That's not possible in VMware. You still need the VMware guy to get that job done for you, right? That's the difference.
yes.
Okay. And a public cloud is, of course, the public cloud where all of your infrastructure is in there in the public, right? Nothing is there in the private. And hybrid is a combination of public and private, where a part of your infrastructure is there in your private environment and a part of your infrastructure is there in your public cloud. There's a term that you see on the screen which is called as cloud bursting. That is a new word that you see here. What's cloud bursting? I gave you an example of an e-commerce site, which is, let's say the picture, the diagram that you see, right? So these are the number of servers that you have: 1, 2, 3, 4, 5, 6, and let's say all of them host what? A web server, and then you declare 70% sale, 70% off on a sale from Monday to Friday. What's going to happen? The traffic will really increase, right? Now, you as a system administrator has to provision a couple of more servers, which can be done. It is possible in the virtualization environment as well, but you don't want to do that because the base machine has just 128 GB of RAM, which is already consumed by those 6 servers. Let's say, yeah, the 128 GB of RAM is already consumed by those 6 servers, and there is no space to provision new servers, right? That means you do not have new hardware in your office as well. So what do? You take advantage of the cloud. And let's say anytime there is rapidly provision of, let's say anytime there is a threshold of 60%, I'm going to provision a new server in the cloud instead of provisioning on my premise. So that means that a part of my infrastructure is there in the cloud, and I'm bursting out a part of my traffic into the cloud when there is a demand, and when there is no demand, I'll just kill that machine and I'll continue to use those 6 machines that I have in your premise, and I just pay for what I've used in the cloud. That's what cloud provisioning means. The cloud bursting means. Make sense?
Yes.
Everybody. Okay. Sindhu, yourself as well? All right, thank you. Community cloud. Community cloud is where like-minded organizations, let's say financial companies, or the companies that have a lot of intellectual property, or let's say maps, which they don't want to disclose it to anybody, and they think that a cloud is not secure, and I don't want to keep it there. They will create their own cloud environment where only they will be able to access it. So there will be a lot of collaboration. It is cost effective for those companies, and they do not have to choose Amazon, do not have to choose AWS or Azure for that matter. They can create their own cloud, right? That's what, since we're talking about that, also take a look at OpenStack. Also take a look at a tool called as Proxmox. I'm putting that in the chat, and keep that as notes. Whatever notes I'm typing in the chat, let it go to one notebook. Just scribble it there, so that at the end of 10 days you will have a lot of material to look at, and that will be helpful for review as well. Okay. All right. There are different deployment models. We're just talking about on-premise and off-premise, the advantages and disadvantages. The cost is very high. We know for obvious reasons, cost is very high. In off-premise, the cost is less. That means the cloud cost is less. The time it takes to provision a resource in the cloud is less. Time it takes to provision a resource on your premise is very high. Troubleshooting is entirely your responsibility when it is on your premise. In troubleshooting, you can take the help of the cloud vendor just in case things go wrong. Availability, 100%, it's your responsibility when it's in your premise or in your office. But availability is the responsibility of the vendor, right? If something goes down, you can question the vendor. Security is of course very high in your premise, but again it depends on SLAs when it goes to the cloud. Hardware ownership, 100%, it lies with you as a company when it's on your premise. Hardware ownership is 100% with the service provider when it's in the cloud. The data ownership is 100% on your premise when it's with the customer when it's on your office. But again, it all depends on the SLA when it goes to the cloud. SLA stands for service level agreements. SLA stands for service level agreements. Yeah, so take that a look as well. Go to. Now you need to understand something called as ITIL. ITIL. ITIL stands for Information Technology Infrastructure Library as well. So a lot of organizations, so being in the infrastructure side, you have to be ITIL certified. Not you have to be, but if you have it, it's good. If you don't have it, companies may ask for it. But there are a lot of management skills that you may have, like incident management, there is risk management, vendor management, change management, data management, risk management. So all of these things which fall under ITIL, give that a look as well. Tomorrow, if you don't understand those, I'll be very happy to repeat that and say, hey, I didn't understand what ITIL is. I did go through Wikipedia and all of those things in Google. I didn't understand that. That's fine. You can come back to it. But I want you to put certain efforts to learn things, right? There's now going to be any spoon feeding here. There's going to be a lot of homeworks. And then, of course, you have the right to come back and say that, hey, I didn't understand that. So that way, you will be keeping it more interactive, and then you will have certain things to do as well. All right, guys, so we move ahead.
Okay.
Okay, I hope I'm not confusing you with bombarding with a lot of these words and jargons, yeah? The idea is to give you awareness.
Yeah.
All right, let's go ahead. Deployment model in the cloud. So again, data segregation. So when you talk about software as a service, examples of which are Gmail, SkyDrive, the data segregation is very high. But in platform as a service and infrastructure service, you can control the data, or what kind of data you're putting in. The database is something that you as a customer can control. But in software as a service, you cannot control that. You have no control over that. And when I say that, you know, you cannot control the number of rows, tables, columns in Gmail, right? We don't know what database that they're using, right? So that way data control is very less. But in platform as a service, everything is in your control. You can create the tables and rows and columns, delete them, purge them, write your own lifecycle policies. Yeah. Infrastructure as a service, again, you have control over that. Network isolation, again, in Gmail we have no control over what network that they're using, but in platform as a service and infrastructure as a service you have uh, control over that. So network isolation is less, so that way you can control where, in which data center do you want to put that in which country, in which region. Yeah. Checking laws and regulations, it's your responsibility. For example, keeping the data out of the country is not allowed in Germany. Using Google is not allowed in China. Using WhatsApp calling is not allowed in the Middle East. Viber calling is not allowed in the Middle East. So it's your responsibility. If you're creating an application doing certain things, it's your responsibility to check the local laws and regulation. Amazon will give you everything. But then if you're going beyond certain things, creating an application that is not allowed in that country, so we gotta be watchful about that, right? You have to do your homework. We understand what cloud bursting is. I told you about that example about the e-commerce application where you got 6 servers and then the load really goes high and then you create a server in the public. Yeah. Orchestration is nothing but a workflow, right? It's a very essential way. So you want to create a virtual machine in the cloud, you should be able to do that. In the background, what kind of orchestration happens, what are the various things that are happening in the workflow, we as customers don't have to worry about. Orchestration is nothing but an automation that functions as a workflow just with a single click of a button. So when you say launch instance, the instance launches, but then in the background there's a workflow happening. There's a checklist that's happening. Check, 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 check. If everything is good, the machine is launched. If not, it gives you an error. So orchestration is an automated way to do or to get your jobs done in an automated way. Are you good so far?
Yes.
Sindhu, yourself? Okay, great, thank you. So let's go ahead. All right, so I was talking about accountability and responsibility. There's SAS, PAS, IAS. I would like you to give this a read and understand what's written in there. I'll give you a minute to read that. If you understand it, then let's go. If not, let me know. Time starts now. Please let me know when you're done by typing done in the chat. Are you done? Alright, Vivek says done. Bandhavi done. Sindhu, you done as well? Alright, great. Do you understand as well?
Yeah, most of it.
Okay.
Like outages, it's a kind of fluctuations or errors in, or
Yeah. Outage. You want to understand the term outage?
yeah, yeah.
Okay. Outage means when a server is down, that is an outage. So when a web server is down, the web application is down, that is an outage.
Okay,
Let's say you don't get a signal on your phone, that is an outage.
okay. It's a kind of fluctuation or error, I can say.
No, you cannot say it is an error. It's a
Uh,
problem. Uh,
okay,
an outage
but
is
not a but. Yeah,
widespread. An outage is widespread. You know that internet cables go under the ocean, right? So if there is a shark that
yes.
comes and bites it, there's going to be outage in that particular region. So outage is widespread.
Okay.
A scheduled outage can also be done. Let's say I want to restart a server and the dependency on that server is very high. There are 1,000 customers that are connected to the server at that point in time. Let's say WebEx. So we are
Mhm.
using the GoToMeeting server, right? We're using the
Yeah,
GoToMeeting server to talk and they want to restart the server. That means that all the voice connections will drop down. That is an outage.
yeah.
A scheduled
Okay.
outage is usually done in the companies at non-business hours, usually during Saturdays and Sundays. Um, or in certain Middle East companies, they do it during Fridays and Saturdays, right? Or companies choose long weekends to do outages if they want to restart a server after patching it, right? So that is what scheduled outage means. Anything else?
No.
Sindhu, which part of it you did not understand? Yeah, okay, outage, all right. Bandhavi, how about you? Thank you. Okay, great, thank you.
But yeah, so it would be easy, like more comfortable if you could go take us to the flow, like regarding the slide,
Yeah, absolutely.
because we can. Yeah.
I usually do this, Vivek. I ask you to read as well because I really want interactive sessions here. Uh, phone on mute, please. I always wanted interactive sessions where people talk and come out because I don't want people to be distracted. So that's why I do this kind of activity somewhere in the middle of the screen. People may think that, hey, this guy is asking me to read the slide, but that's worth it. So you focus here and understand each of those terms, and then you come back with questions. If I explain all of this and say, hey, any questions? You will say, no, I don't have any questions. But then when you read it, you'll put your heart and mind into it and then come out with questions. So that's the objective. I'm not trying to skip my work or my job of being training you people, but then this activity keeps people interactive, and then there's a food for thought that you also think about. So that's how it is. There's no other intention. So accountability is the customer is responsible for your own data. Let's say you create a virtual machine on the cloud and you put a lot of servers on it and that server goes down. That's your responsibility because you got to make sure that your data is backed up, right? If there is an outage that is happening because of some reason, then you got to make sure that you design your systems accordingly so that the server can survive a disaster. Your designing must be in such a way. So you replicate your data across geographies. So if you have a server in North Carolina, you replicate it to the West Coast. And if your data is in West Coast, you replicate it to Singapore. So just in case there is a man-made disaster happening or a natural disaster happening in a particular region, you will have your data safe in a different place. Isn't it? So just like you back up all your photographs into the cloud, just in case you lose your phone or phone gets corrupted, you will still have your data in the cloud, like your Google Photos or somewhere. That's what it is talking about. Make sense, guys? Okay. All right. So again, number one, cloud consumer is responsible for their staff, operational policies, and correctness of their data. Cloud consumer is who? We, right? We are not the vendor. So I am using Amazon Web Services. I am the cloud consumer. So I am responsible if one of my staff messes up with my data, messes up with the operational policies, and it tries to delete certain things, right? Virtual appliance supplier is responsible for the software. Somebody is providing load balancers to them. So it's just a segregation of responsibilities. Amazon Web Services is not doing the job alone. They are not producing cables and wires. They are not providing load balancers. They are providing load balancers, but they are not manufacturing load balancers. They are not manufacturing the servers, the physical racks. They are not manufacturing the air conditioning inside that, right? They do not have their own electricity power supplies, right? So when something goes down, a load balancer goes down, a server goes down, electricity goes down, the respective vendors are responsible for that. When a load balancer goes down, the manufacturer of the load balancer is responsible for that. When electricity goes down, the electricity vendor is responsible for that, right? So responsibilities are split up. Amazon cannot be held responsible for everything if something goes down, right? That's what this slide says. Good so far? All right, that's good. Moving on to another concept, which is storage. Everything is a storage, and in this example, I was talking about where's the picture? Yeah, in this example, I was talking about storage area network. The storage area network, everything has a it's like a couple of petabytes of storage that you can think about. Lots of petabytes of storage, right? That is something on the storage, and that needs to be appropriately distributed to those virtual machines. And that can only be done if every block of that data has an object ID. Every object that is stored on that storage has an ID that is very unique. That object ID is a 64-bit ID. So that will help you store the information on the storage, search the information on the storage, and also retrieve data across the internet, because that is stored somewhere on a large partition like SAN, storage area networks. Forget about your hard disks, which are like 1 terabyte or 2 terabytes or whatever. That is very small. When we talk about large storage, they are storage area networks which are much larger in size physically as well. They're as big as an almara, and usually by companies like EMC, and then there is Hitachi storage. You can search for storage from EMC Square or Hitachi. You might have heard of these companies. They're massive ones. And then every piece of information that you store inside that is called as an object ID. And every object has a metadata. For example, the text file that is stored on your desktop has a metadata. Like, what is a metadata? Metadata means data of data. Data about that text file. The last modified date, last accessed, security, where is it stored, the path, all of that is metadata. Whether it is encrypted or not, whether it is compressed or not, it's all metadata, right? And blobs are very large objects which are stored in binary format. That's what blob means. Okay. There are some more aspects of object storage. Then there's a summary. It's fine. There's a quiz for you guys. So you can post your answer in the chat or maybe unmute yourself and talk. So
I think I'm confused between A and C. It's Gmail is of course a software as a service provider, but it's for private or I think to some extent it's private. Like initially we get 15 GB of data we can use in, but if we want more we have to purchase in.
right. A private cloud is accessible only within that organization. That means only Google employees can access it. But because it is accessible from the internet,
Okay.
it's public.
Okay. So it's C. The answer
That
is
is
C
true.
then.
Right. Next one.
No, it's false. B.
Alright, I got one answer. Somebody says false. Everybody. We need two more answers, please. Mandvi and Sindhu. Alright, B. Alright, understand. Okay, I didn't get the question. What does measured service mean? Sindhu? It's one of the 5 key characteristics of cloud computing where everything should be measurable, not just the billing but monitoring as well. Right, so that is B. Please take a look at the explanation. Alright, next question please. Okay, the answer is B.
I think it's B.
Yeah.
Yeah, platformers. Platform is where the code is written and
Right. Everybody agrees to that, I hope, yeah? Next one, please. Alright, so that's A. Alright, that's software as a service. Okay, let's go ahead with that one, please. Alright, answer is A. Yeah, Madhvi, you're right. Thank you. Well, that's a big thank you from me now. Thank you for your patience and listening to me. Appreciate your time. So remember the homework, right? Everybody who's not tried virtualization would really like, go ahead and take a look at that. Install those softwares. Install yeah, it's caps lock. Install the tools on your machine, VMware Workstation. You get a trial period for that from the VMware side. And there's another one which is Oracle Virtual Box. It's free, so you don't have to worry about that. Also download a Windows ISO, which is Windows 2008 R2 ISO on your laptop, and create a VM out of it, right? Create a VM. So that's your task for tomorrow. Hopefully that will be done. Every day you will get tasks like this. So that ways you'll be very busy. Okay. So if you would like to keep that in your notes, that is in your, that's it. Okay. Any questions for me before we wrap up today's session? Oh
Yeah.
yeah, I actually made a video out of the demo that I was giving. Let me just quickly share that with you, just in case if you're looking at video. You need a website. Close that and yeah, that's my video. So if you gotta wanna take a look at that, you can take a look at it. No problem. A lot of questions and answers inside that, so that's gonna be beneficial. I keep making videos there and posting it to YouTube, so that ways it will be helpful if you subscribe that. Else that's fine. All right, guys. Since you got no questions, so we're gonna wrap up for the day and have a good one. We'll see you tomorrow again. Thank you. Bye bye.